As a physicist, Dr. Kei Takashina knows that even the simplest phenomenon can produce great complexity.
You just drop the water on the surface. So you have three phases of matter coexisting and interacting with each other already. And the question is, what happens and why?
Drop water on a heated surface, and it slowly boils and evaporates. Heat up the surface some more, and the water sizzles away instantaneously. Keep increasing the temperature, and suddenly the droplets coalesce and float above the surface. This is the Leidenfrost effect. First described in 1756 by a German doctor, Johann Gottlob Leidenfrost, the effect only occurs when a surface reaches a temperature so hot that it creates a thin layer of vapor between itself and the liquid, in effect insulating it and dramatically slowing down any further vaporization. Although it's a common sight while cooking,
it is something that is commonly overlooked, I would say.
Dr. Takashina's own interest in the effect didn't start in the kitchen.
A friend of mine emailed me a link to this paper in Physical Review Letters by Heine Linke.
Entitled Self-Propelled Leidenfrost Droplets, the paper reported a way to move beads of water across a heated surface covered with stair-like ridges. As the droplet encountered a ridge, the flow of vapor beneath it pulled it up and over, even when the surface was on a slight incline. With no moving parts, the process could potentially be used to cool an overheated microchip inside of a computer.
And it looked so interesting. I mean, you have to try it, right?
So Dr. Takashina and a group of physics undergraduates at the University of Bath got to work building and testing different ridged blocks. Right off the bat, the team noticed
the sharper the teeth are, the steeper the angle they seem to be able to climb.
And this led them to wonder what else would affect the droplet's ability to climb.
So at very high temperature, the droplets become completely levitated. And there, they can't climb very steep inclines at all. The steepest angle they climb is achieved at a lower temperature.
Here the droplets weren't 100% levitated. They still had contact with the surface, and this allowed them to grip its teeth. But as the team started using temperature to precisely control the ascent of the droplets, they noticed
that depending on the temperature of the block, the water would move in different directions. And this is completely unexpected.
And really cool. When the surface was heated over the Leidenfrost point, the droplets curved to the left. If they were under, they veered to the right.
There must be something in the structure of the surface.
Upon magnifying the ridges, the team noticed that they had small grooves,
which we think is responsible for the directionality.
And as one might expect from a team of undergraduates, a creative idea took hold.
If you arrange the blocks in the right directions and you put the walls in the right places, it will work.
Behold the Leidenfrost maze.
With the water, it's immediate. You can see it, you can hear it. Can we use this effect to engage people who are otherwise not so interested in science?
To which we say, full steam ahead. For Science Friday, I'm Luke Groskin.